Raising heavy timber without a crane is a dangerous puzzle. Today, one builder relies on a compact excavator and raw precision to frame a massive backyard pavilion. The foundation of any lasting timber frame is established long before the wood ever leaves the ground. This build demands massive structural beams to span an expansive outdoor living area. Every joint must bear immense weight and withstand decades of seasonal movement. The craftsman begins by scoring the layout lines with a utility knife, severing the top wood fibers to prevent splintering when the saw blade bites. A reciprocating saw is used to plunge deep into the timber, carving out the heavy waste material. The resulting rectangular notch is the female half of a robust structural connection. The geometry relies on tight tolerances rather than mechanical fasteners alone to carry the load. Wood-to-wood joinery distributes compressive forces evenly. Elevating heavy timber requires anchoring that goes deep into the earth. The builder sets the vertical support columns into deep excavations, pouring a wet concrete mix directly into the void. This encasement creates a massive friction footing, locking the posts against intense lateral wind loads. Alignment is critical during the wet phase. A taut string line ensures the entire row remains perfectly plumb, while the concrete undergoes its exothermic curing process. Once the cement hardens, these bases become unyielding anchors, tying the heavy overhead canopy directly to the soil. Preparing the overhead spans requires specialized hardware pathways. The craftsman uses a power drill to bore deep cylindrical channels through the heavy beams. These cavities will accommodate structural lag bolts, creating rigid mechanical bonds at the primary load-bearing intersections. The precision of these pilot holes is paramount. they guide the heavy steel fasteners straight through the core of the timber without splitting the grain. A quick sanding removes the fibrous tear-out. Custom fitting the overhead architecture involves precisely mapped subtractions. The builder uses a circular saw to slice a clean notch out of the heavy horizontal span. Removing material at the intersection points allows the beams to interlock seamlessly, lowering the overall profile while massively increasing the shear strength of the connection. Once the structural milling is complete on the ground, the massive timber is hoisted atop the columns. This is where the geometric planning pays off. The notched beam drops directly onto its mating surfaces, locking the skeletal frame together. A single worker can now secure the elevated assembly with a power drill permanently anchoring the heavy transverse, loads high above the patio floor. Machine tools often leave blunt corners and tear out that prevent a perfectly flush fit. The builder turns to a high-carbon steel hand chisel to pare away the remaining waste inside the deep notch. Slicing off paper-thin shavings of end grain allows for micro-adjustments, ensuring the joint seats tightly against its opposing member. Moisture and rot cannot easily penetrate a perfectly flush timber connection. With the heavy joinery refined, the architectural focus shifts upward. The intermediate roof rafters are positioned across the primary support beams, establishing the structural grid for the heavy canopy. Each rafter must be secured independently, tying the parallel main spans together to prevent lateral racking under high winds. These evenly spaced ribs distribute the immense dead load of the future roof deck uniformly across the entire skeletal frame. Raw-dimensioned lumber rarely arrives perfectly uniform in thickness. A mechanical thickness planer shaves the rough boards down to a precise, consistent depth, ejecting thousands of curled wood shavings in the process. This dimensional uniformity is absolutely crucial for creating a flat, predictable roof deck. Inside the workshop, the builder feeds the freshly planed stock through a table saw, ripping the wide boards into identical, narrow slats. This intense, repetitive milling phase transforms raw timber into uniform architectural components, ready to be installed as an exposed overhead ceiling. the overhead slatted decking serves a dual purpose. It provides the rigid structural substrate for the final roofing material, while simultaneously acting as the visible, aesthetic ceiling from below. The builder works across the top of the open rafters, securing each narrow plank with a pneumatic nail gun. The high-velocity fasteners sink deep into the grain, rapidly locking the decking grid together. To maintain a perfectly straight edge along the perimeter, the boards are intentionally left long. A single, continuous pass with a circular saw will later trim the rough overhang, leaving a crisp, factory-straight architectural line against the sky. Integrating modern electrical utility into raw timber construction requires custom fabrication. The builder constructs specialized wooden mounting blocks designed to house the recessed lighting fixtures. Precise measurement ensure the circular metal housings will fit tightly within the wooden collars, preventing ambient moisture ingress and eliminating rattling in high winds. After an aggressive sanding pass smooths the sharp corners, a dark, penetrating wood stain is applied. This chemical finish soaks deep into the grain, matching the modular blocks to the massive overhead beams, while protecting the exposed wood fibers from atmospheric humidity. Finally, these completed light assemblies are hoisted up and secured directly to the underside of the roof. Housing the electronics independently protects the primary structural frame. Bringing power to an isolated structure demands subterranean infrastructure. Gray PVC conduit is laid into a shallow trench, providing a waterproof, crush-resistant armored pathway for the electrical feed. Burying the line protects the sensitive copper wiring from ultraviolet degradation and accidental lawnmower strikes. At the structural terminus, the conduit transitions into a weatherproof wooden junction box. Here, the builder strips the thick insulation, making the critical hardwired connections that will power the overhead canopy system. A flat roof requires an impenetrable barrier against standing water. The builder drags heavy, continuous sheets of black roofing membrane across the structural deck. To join the overlapping panels permanently, soapy water is sprayed along the critical seams. This temporary lubrication allows the installer to slide a specialized pressing tool along the junction, aggressively forcing out trapped air pockets. A flawless seal prevents capillary action from pulling rainwater beneath the protective membrane. Controlling water runoff is the final defense for the timber frame below. A bead of waterproof silicone sealant is applied to the metal gutter joints, creating a flexible, watertight gasket between the modular sections. The builder mounts the continuous black gutter directly along the lowest edge of the slanted roof deck, catching and redirecting the shed rainwater, prevents destructive soil erosion around the freshly poured concrete footings at the base. Expanding the outdoor living space means rerouting existing infrastructure. The builder excavates around the pressurized pool filtration system, slicing into the rigid PVC plumbing lines. Rerouting these heavy-duty pipes ensures the mechanical water systems clear the footprint of the heavy paver patio about to be laid. A gas-powered masonry saw uses a diamond-impregnated blade to slice through the dense concrete pavers. Cutting custom angles allows the hardscape to cleanly bypass structural posts and existing barriers. Each heavy stone block is gently slid into its final resting place over a highly compacted gravel base. A rubber mallet dials in the final level, ensuring a perfectly flat, trip-free walking surface. To lock the heavy stones together, polymeric sand is swept deeply into the narrow joints. This specialized sand contains chemical binding agents that activate upon contact with water. Once the excess dust is blown off the surface, a light misting will turn the loose sand into a flexible, weed-proof mortar. The lowest foot of a timber structure takes the most atmospheric abuse. A palm sander opens the wood grain before a heavy protective stain is applied to the columns. Extensive plastic masking is taped down to shield the pristine concrete pavers from permanent chemical drips. The dark finish seals the porous wood fibers against ground moisture and intense ultraviolet radiation, drastically extending the lifespan of the vertical supports. The rough, exposed ends of the roof rafters are vulnerable points for water intrusion and rot. To seal the perimeter, the builder installs wide wooden fascia boards along the outer edges. Fastened with heavy structural screws, these long horizontal bands cap the end grain of the timber grid. Beyond its defensive role, the fascia provides a clean, unified architectural border, masking the layers of roofing membrane and rafter tails behind a smooth, finished facade. The massive wooden frame is now fully enclosed, braced against lateral forces, and protected from the sky. The final aluminum downspout completes the water management system. In the end, heavy timber, deep concrete, and precise geometry operate as one resilient shelter, a space forged from raw labor, now